In the previous lessons, we learned how to use the stoichiometry flowchart. And basically, we always start on side A, which we have the chemical and the unit. And we always end on the unit and the chemicals of the unknown. In this lesson, we are going to look at how to use the stoichiometry flowchart with a chemical reaction. And one most important thing is this chemical reaction need to be balanced, or the chemical equation need to be balanced. Well, let's try this particular problem. We have hydrochloric acid is extremely corrosive and it reacts with most metals, except for unreactive metals like gold and copper. When aluminum is added to a solution of hydrochloric acid, the aluminum will react with the acid to form pure hydrogen gas and aqueous aluminum chloride. Well, that's a lot of words, isn't it? But if you notice, it doesn't have any important information about this chemical reaction. It's just telling us what's happening here. We already have this already. So we don't really need those information anymore. So it's cross out so that we don't get tricked by it. Now, how many moles of hydrogen gas? We are asking a question. So in this case, it's question mark moles of hydrogen gas, will be produced if all of 1.7 moles of aluminum is reacted in a solution of hydrochloric acid. Now we have our given values, 1.7 moles of aluminum. So basically, when you read this type of problem, there's two things you're looking for. The given and the unknown. And once you figure that out, the rest of the problem can be ignored. So we always start from our given, which in this case, moles of aluminum. So always on side A. So this is where we are going to start, mole. And where are we going to stop? In this case, and we are going to stop at moles of hydrogen gas. And notice how aluminum and hydrogen are two different chemicals. So therefore, we had to go to side B, which exactly, in this case, is mole, which is mole right here, and moles of B. And turned out to be just one conversion factor, which is that one right there. So all we have to do is take your given, in this case, 1.7 mole, of aluminum, time, starting right here, which is where we start. So we start from a given 1.7 moles of aluminum, time the conversion factor, in this case is only 1. So that is the number of moles A equal to the number of mole B, And we always label our given chemical as the chemical A. And if the chemical of the unknown is different, we're going to label that B. And that is how you use the stoichiometry flowchart with a balanced chemical reaction. And that's all we have to do. Now the rest is just substitute in the values. In this case, I know the chemical A is aluminum. And the chemical B is the chemical of the unknown, which in this case is H2. And what do we have here? That number right there, right in front of those two chemicals. And if we look at the flowchart, it tells us right there it is the coefficient because we are dealing with chemical reaction. Remember, we used subscript before when we deal with compound. Now we have chemical reaction. So what is the coefficient in front of aluminum? So find aluminum, there you go, is a 2. What about hydrogen? Find hydrogen, that's a 3. And we are pretty much done. We don't have anything else to substitute in. And the rest is just rewrite this as fraction. So we can multiply it. So we have 1.7 moles of aluminum time this conversion factor as a fraction. Notice this is moles of aluminum. So therefore, down here must be mole of aluminum as well. So 2 moles of Al. And the leftover part, which is the other side of the conversion factor, has to be on top. So we have 3 moles of hydrogen gas. And notice how mole of aluminum cancel each other out. Simplify to equal to 1. And all we have to do now is just multiply everything on top, divide everything on the bottom. So at 1.7, time 3 divided by 2, because the 2 is on the bottom. So our answer is 2.55 mole of hydrogen gas. There you go. So what does that really mean? Basically, if you have 1.7 moles of aluminum in this reaction, it will make 2.5 moles of hydrogen gas in the end. And that's how chemical reactions work. You're starting with one materials and you make a completely different substance. Now let's try another problem. In this case, this problem is the same scenario, so we can ignore all this facts about this chemical reaction, okay? But getting to the point of the whole entire problem, where the given and the unknown will be provided to us, how many moles of hydrogen gas again? Oh, moles of hydrogen gas again. The same one as we did before. Will be produced if all of 3.5 grams of aluminum. Oh, in this case, we're not starting from moles, but now our given is 3.5 grams of aluminum. So we changed the unit, right? And is reacted in a solution of HCl. That is not really important. But now, after we figured out our given and the unknown, let's go back to the stoichiometry flowchart. Our given is no longer mole of aluminum like the last problem, but now it is grams. So how would that change the problem? So always start on size A, which in this case, oh, here's grams. So we are going to start right there. This is the only place on the flowchart that has grams on side A. And we are going to go to where? We're going to mole of B. How do I know it's mole of B, not mole of A? Because the chemical is completely different. So in this case, this is where we are going to end. So we're going down and we're going across. So this is our first conversion factor, and that is our second conversion factor. Boom. Pretty much done. That's all we have to do with the stoichiometry flowchart. Now, all we have to do is just rewrite this, starting again from our given, which is 3.5 grams of aluminum, time our first conversion factor, which is this one right here, is 1 moles of A equal to the number of grams of A. So the first conversion factor that we multiply to is this one, which is 1 moles of A equal to the number of grams of A. And then we're pretty much done. Now let's move on to the next conversion factor, which is the number of mole A equal to the number of mole B. So the number of mole A equal to the number of mole B. And that's it for the stoichiometry flowchart. Next, we're going to substitute in what we know about the stoichiometry flowchart. In this case, we know that we use the letter A to represent the chemical, the given, and therefore B must be the chemical of the unknown. So I can just change all the A to aluminum, okay, all the A to aluminum, and all the B to hydrogen gas, okay. Now, let's look at this conversion factor. We have 1 moles of aluminum equal to the number of grams of aluminum. What is that number of grams going to be? Of course, it's going to be your molar mass of aluminum, which we can use the periodic table. But in this case, it's given to us. So we have, what is it? 26.98. So 26.98, that is the molar mass of aluminum. What about the number of moles of aluminum and the number of moles of hydrogen gas? That is coming from your coefficient, because we are dealing with chemical equation, okay? So when we have a chemical equation or reaction, we are dealing with a coefficient. What is the coefficient in front of aluminum? Again, it is 2. So therefore, this must be 2. What about hydrogen? It is 3, so this must be 3. And we are pretty much done with the substitution part, right? All we have to do now is multiply everything as a fraction. So in this case, we start with 3.5 grams of aluminum and multiply our first conversion factor, which we're going to convert into a fraction. If this is grams of aluminum, down here must be grams of aluminum as well. So it's 26.98 grams of aluminum. And the top part must be the leftover part, which is 1 moles of aluminum. And we are pretty much done. Now let's go on to the next one. In this case, notice how we have gram cancel each other out, and we multiply to the next conversion factor. In this case, if we have moles of aluminum here, somewhere in this conversion factor must have moles of aluminum, which is right there. So 2 moles of aluminum, and the top part must be the leftover, which is 3 moles of hydrogen gas, which is exactly what we look for, okay? And moles of aluminum cancel each other out. Now all we have to do is plug this in a calculator. Multiply everything on top, 3.5 times 1, which we can ignore. So we go times 3 then, and divide everything on the bottom. The first one is 26.98, and the next one is 2. So our answer is 0.195. So 0.195, and this case is moles of hydrogen. Boom, we are pretty much done with that problem. Now let's try one of the most challenging problems that deal with stoichiometry. And we are going to look at a different chemical reaction. And basically this chemical reaction is making table salt, which is NaCl. So sodium and chlorine gas are react to make table salt. Sodium chloride, NaCl. How many grams of sodium, which is Na, are needed to complete the reaction if 5.7 grams of NaCl is collected after the reaction? So here, the first part is irrelevant. It's just facts telling us this right here. And we have a balanced chemical equation. We know that already. And the first thing we have is the given, which in this case it is 5.7 grams of NaCl. And again, when we read this type of problem, we are looking for two things: the given values, along with its unit and chemical, and the unknown. What are we looking for? In this case, it is grams of sodium, so it's question mark grams of Na. So now let's use our given, which is grams of A, right? We always start and say A. So that's where we start, and we're going to where? Well, our unknown is grams of sodium, which is a different chemical. And that makes sense. So now we're going to be adding all the way over here in grams of B. So to get from here to there, this would not be possible. So we had to go down. That's why I say follow the flow chart, going down, and we go across, and we go up. So in this problem, we had to multiply 1 conversion factor, 2 conversion factor, and 3 conversion factor. So in this problem, we take a given and time 3 conversion factor to solve for the mass of sodium. So let's write this using our stoichiometry flow chart. Again, always start from your given 5.7 gram, in this case of NaCl, time our first conversion factor, which is that one right there, 1 moles of A equal to the number of grams of A. Isn't that easy? And then our next conversion factor is number of moles A equals to number of moles B. And our last conversion factor is 1 moles of B equal to the number of grams of B. And the next step is substitute into your flowchart. And of course, the chemical A is always the chemical of your given, and therefore this must be the chemical B. So here we have A, which is going to be NaCl. So everywhere I see A, I can put NaCl right there. Okay. Now B would be Na. Isn't that easy? That would be Na. There you go. Now, if we notice, we have the number sign everywhere. Where is this number coming from? The number grams of NaCl. Well, that's your molar mass. It says right there on your flowchart, molar mass. So what's the molar mass of NaCl? Well, it tells us right here, 58.40. So 58.40. If you don't have it, use your flowchart, okay? Solve it from there. And we are done with this conversion factor. Now we're moving on to this right here, moles of NaCl equal to moles of Na. And we are dealing with a chemical equation or reaction. This must be the coefficients. What's the coefficient of NaCl? That's a 2 right there. What about for Na? It is 2 as well. So turn out to be 2, 2. And the last conversion factor, we have 1 moles of B, which is, we know, is Na. And what about the number of grams of Na? In this case, is the molar mass, which is from the periodic table or right here, which is 22.99. Now we have substitute everything into our flowchart. Let's multiply it as a fraction, okay? So we have 5.7 grams of NaCl time our first conversion factor, which we have to convert it into a fraction. So here we have grams of NaCl. The gram of NaCl must be on the bottom, so exactly 58.40 grams of NaCl. And notice how it cancels each other out, okay? And the other side of the flowchart must be on top, which is 1 mole of NaCl. Now we are done with this conversion factor. Let's move on to the next conversion factor. Notice how we have moles of NaCl. The next conversion factor must have moles of NaCl somewhere, so which is right here. So it's 2 mole of NaCl So this side is done. Now the other part must be on the top, and which is 2 moles of Na. And we are done with that conversion factor now. Let's move on to the next conversion factor. Notice how moles of NaCl cancel each other out, and we have moles of Na left. So on the last conversion factor, this must be moles of Na as well, which is right here. So we have 1 mole of Na. The top part must be the leftover, which is 22.99 gram of Na. Now everything have canceled out except for the unit and the chemical that we are looking for. So let's plug everything into the calculator. And the rule is multiply everything on top, divide everything on the bottom. So in this case, we have 5.7 multiply 1, which we can ignore, multiply 2, and then multiply 22.99, okay? And divide everything on the bottom, which is 58.40, and divided by 2, and the 1 we don't care about. So the answer is 2.24 grams of Na, and that is our answer. What does that really mean? That means in this problem, to make exactly 5.7 grams of sodium chloride, which is your table salt, you need to put in 2.24 grams of sodium to react with the chlorine gas to make that much 5.7 grams of table salt there. And that's how chemical reaction works. You're starting putting in some chemicals, and they react with each other and make a different product.